can answer the questions, please go ahead and answer the questions. If not, please just send me a message in the chat and let me know, to everyone, to the general chat, and let me know if you'd like us to go through these questions together. These are some of the more simple questions, so I hope you guys are okay with these. Yeah, and I'll just give you guys a few minutes. If not, and you're like, ma'am, please help me, I don't know where to start, then I'm more than happy to do that. Just move my charger out of the way. Okay. All right, guys, in the next 2 minutes, I'm going to start putting answers on the screen. So I hope you guys are trying out the questions. If you need my help, I am here to assist you. Just let me know in the chat, or you can raise your hand and we can have a bit of a conversation. Or if you're feeling a bit shy, you can DM me or Teacher Nelly. She's here with us. Hello, Teacher Nelly. So,
Hello, everybody. So sorry, I came in late, so I didn't want to step off. Like, it's fine, I'll be just at the back. I don't have to greet everybody. But since we're here,
no, absolutely. I'm the student
Watobe
today.
Exam revision lesson. So yay, we have the incredible Miss Coco with us here, because honestly he couldn't be with us today. So
keep the compliments coming. Thank you, Teacher Nelisa. Awesome. Yeah. All right, let's give them a couple of minutes.
Yeah.
Guys,
and please post your answers in the chat. I know you guys, you just be focused on your work, doing the work, but please share your answers with us. We really appreciate that, please.
Just give you guys a bit of a refresher here quickly. In case some of you have forgotten how to do first principles, there's our target over there. That's the formula for first principles. All right, let's get going. All right. No worries. Don't know who SL Bavuma is, but thank you for joining us. Okay. X is equal to 2x squared minus 3x. Remember, guys, this is the process that I'm going through in my own head. So if you guys do this differently, you're more than welcome to do it in whatever way you guys find comfortable. Okay. Sure. Kulani is already there for us. Okay, excellent. Right, so this is what I'm going to be subbing into my formula as we go. All right, so zero of, I'm going to put it in brackets quickly. 2x plus 4xh plus 2h squared minus 3x minus 3h, and I'm going to run out of space again. Whew. I'm going to have to figure out how Teacher Lee does this without taking up all the space, because clearly my handwriting is huge. Okay.
She's
minus.
also always moving stuff around, so.
Okay. All right. That makes me feel a whole lot better. All right. There we go. All of this over h. Okay. And then I remember, guys, I need to carry my limit with me. It needs to keep coming with me until I get to the very end where I solve for h. Okay. This is going to give me 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus x all over h. And my 2x squared minus 2x squared will cancel. Negative 3x plus 3x cancel. And more space. Yeah. Okay. This is equal to h over 0. And I will have 4xh plus 2h squared minus 3h all over h. And that means I can take h out as a common factor. So h approaches 0, take out h at the top, then I have 4x plus 2h minus 3 all over h. And then now the two h's will cancel. And I will have limit as h approaches 0, 4x plus 2h minus 3. And then I'm eventually going to sub my h in, which means that because h is approaching 0, this part over here will become 2 multiplied by 0, which will become 0. And what I will have left is equal to 4x minus 3. Okay, if you guys are feeling confident, can I ask you to give me a thumbs up, thumbs down? Did we follow this exact process, guys? Remember, when we're doing first principles, we are not looking for the answer. We know you guys can do the derivative. The derivative is very easy. We have a shortcut. What we're looking for is for the method. And that's why it's worth so many marks. We're making sure that you guys remember to continue your limit, to look for x plus h, to look for f of x, put all of that together as you go along until you get to the derivative. And that's what we are worried about. We want to make sure you guys understand the steps that it takes to get to the answer. So I'm getting like 3 thumbs up. I'm hoping everybody else is okay with this question. You are welcome to take a screenshot if you would like to, because this is kind of the answer and how we got to it. Thank you very much, guys. Okay, and that is easy enough. Now, if we look at 9.2, I think one of you has already done 9.2, which is the easy part. 9.2.1 is pretty easy. Okay, we can look at 9.2.1. It's pretty standard, right? 9.2.1. Okay, if I've got y is equal to 4x to the power 5 minus 6x to the power 4 plus 3x. Then remember, guys, the notation is very important. So they've asked us to use dy dx. So we can't now decide that we want to use y prime. We must use dy dx because that's what they've asked us for. Okay, so we've got to go dy dx is equal to 20x to the power 4 minus 24x cubed plus 3. Okay, I hope everybody's getting the same answer I'm getting. Then we're going to look at 9.2.2. And before we can do anything with this question, let me just move everything down. Guys, you'll excuse me just 1 second. I just want to take this stuff. That's what we're doing next, but I just want to move it down so we have a bit of space. Okay. Before we solve for dx over here, the derivative of x, we want to make sure that all of these indexes, all of these surds are not part of the problem because they make things just so uncomfortable. You don't know, you have to now go and learn what the derivative of the root of x is. No, we don't want any of that. And we know that the easiest way for us to calculate for the derivative of anything is if it's a power, if it's x to the power of something. So we're going to try and rearrange this entire thing in here, and we're going to write it as x to the power of something plus x to the power of something. And that's going to make our lives a million times easier as we're looking at this question. So I'm going to look at negative the cube root of x over 2. And remember, guys, this is just my process. If you don't feel like rewriting everything, that's fine. You can go ahead and do the answer. But it just puts me a little bit at ease to write everything down. Okay, to the power of 2. Now I'm going to rewrite this as negative x to the power of 1 over 3 divided by 2 plus, and I'm going to rewrite this as 3x, I'm lying now, it's still going to be 1 over 3 x to the power of negative 1, all of this to the power of 2. I still have some work to do. Okay, I'm going to rearrange this. Instead of writing negative x to the power 1 over 3 over 2, I'm going to rewrite this as negative a half of x to the power 1 over 3 plus, and then I still need to multiply this in. I need to multiply that in. So I'm going to end up with 1 over 9 x to the power of negative 2. And then finding the derivative of anything, x to the power of something, that's the easy part. But I still need my notation, guys. I need to continue with my notation. I'm actually just going to continue right next to it. Otherwise, it's going to look messy. So I'm then going to look for dx of negative a half x to the power 1.5. Oh, a third plus 1. 9 x to the power of negative 2. And that's going to equal to negative 1 over 6 x to the power of negative 2 over 3 minus 2 over 9 x to the power negative 3. Teacher Nelly, so please just check my maths. Make sure I haven't said anything weird there. Let me know if I've said something out of the ordinary that's lying to people. No, I think I've got this one correct. Okay, awesome. All right, now I'm going to take all my negative exponents and I'm going to take them where they need to go. And this is going to give me negative 1 over 6x to the power of 2 over 3 minus 2 over 9x to the power of 3. Okay. All right. Can I get an indication, guys? How are we feeling about answering that question? It's worth 4 marks. Okay. Yeah, I just need to put that 2 back. S. Albavuma, I think they require you to keep it until you're done. So you would have to put the dx here as well. Okay, so this should be dx. And let me just move my equal signs out of the way. This would also be dx. This would also be dx is equal to, this would also be dx. So I think they want you to keep the dx until you find the actual derivative. Okay. And I'm looking at the memo specifically, and this is how they want you to kind of put it out. So what they want to see actually is how you get to this point here. They'll give you a mark for that and a mark for that. And then they will give you a mark for the 2 final answers. Okay, Oratile, we will look for another one exactly like this one and we can solve that. Okay. Thank you for that. The rest of you guys, I hope you're okay. Please DM us if you guys are feeling like you need a little bit more practice or you want me to go over something again. Please do let me know. Don't be shy. I'm here to answer any question you guys have. Okay. All right. Okay, Oratile, I'm going to look for another question like that for you. And then after that, we'll move on to cubic graphs. I don't know if this one will do. Because I'm actually using Teacher Lee's notes. So I'm hoping that I'm not messing up everything that she's trying to do here. Let me see. Oops. Okay, that's question 10. Okay. Yeah, let's take this one. Gulani's like, definitely a lot more practice, ma'am. All right. Okay, let's look at doing question 8 before we move on to cubic graphs. Okay, just give me 1 second, guys. I feel like I always need to move things down just for space. All right, can we get to doing this one? I'll even make it a little bit bigger so you guys can see the questions a lot more. There we go. And I'll give you guys 5 minutes. Okay. Normally with these kind of papers, we work a mark a minute, but you should be able to do first principle with, it's worth 5 marks. You should be able to get it done in about 3 minutes if you've really practiced how to do it. Okay. See if I can make my pen a little bit thinner. Maybe that will help. Yeah, maybe I'll save space. Absolutely, Kalani, you're right. 8.1, the derivative is 6x, but I can also see it from here. I can see that it's 6x here. I want to make sure that you've used first principles. This is very important. Okay, so we're looking for the procedure, the way that we do it. Not so much that we got the right answer, but that we used first principles to get the right answer. Okay, that's the kicker here. We must make sure we're using first principles to get to the right answer. Okay, I'm going to start putting my answer on the side here. I'm going to do my little rigmarole quickly. Yes, Esabavuma, the limit to where h approaches 0 must stay with you until h is removed. And then only then can you say is equal to this. Okay. Whew. Always takes me a while to get started. All right, let's go. So derivative of f of x is equal to limit as h approaches 0 of, and my formula says f of x plus h minus f of x all over h, which is equal to the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared. Oh, I'm forgetting something. I lie. Minus 3x squared. Okay, mustn't forget the minus 3x squared there. So 3x squared and 3x squared will cancel out. And I will have the limit as h approaches 0 of 6xh plus 3h squared over h. And this will be the limit as h approaches 0. And I'm going to take h out as a common factor. 6x plus 3h all over h. And then the h's will cancel. And I'm running out of space again. Okay, there we go. And this will equal to the limit as h approaches 0 of 6x plus 3h. And now that I am ready to substitute 0 into my h, I can drop my limit, and then I can write that my answer is 6. We can go 6x plus 3 to the 3 multiplied by 0, which is equal to, sheesh, teacher Coco. Okay, there we go. Is equal to 6x. All right. Excellent. Okay. Then we can look at 8.2.1. Okay. Remember, guys, we always want to have x to the power of something and make sure that it's nice and neat when we when we do the derivative. Completely forgetting what the word is. 8.2.1. Okay, we're looking for the derivative. So I'm going to rearrange f of x first. I'm going to go x squared minus 3. In fact, I'm going to take that minus 3 to the end. Otherwise, it's just gonna make my life a lot more difficult. So I'm going to have plus 9, and I'm going to bring the x squared to the top. So it's going to be x to the power of minus 2 minus 3. And then I can find the derivative. The derivative of f of x is 2x minus 18x to the power of negative 3. And this is just the constant. It will fall away. And I'm not done. Therefore, the derivative f of x is equal to 2x minus 18 over x cubed. Well done, Kulani. That's exactly what it is. Awesome stuff. Well done. All right. Then we're going to look at 8.2.2. And again, we're going to have to do some rearranging, guys, because this isn't very pretty and I don't like it. And there's square roots and things that nobody wants. So I'm going to rewrite the square root of x as x to the power a half. And that's going to make my life so much easier. I'm going to write this as x to the power a half plus 3 multiplied by x to the power a half minus 1. And this will equal 2. And then I'm going to do FOIL, top, top, bottom, bottom. Multiply, 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 multiply. It's going to give me x to the power half multiplied by x to the power half will just give me x. And then I'm going to have minus 1 x to the power a half plus 3x to the power a half. And then 3 multiplied by negative 1 will give me minus 3. So what I will have here is x plus 2x to the power a half minus 3. And that's g of x. And that's nice for me because now I can then find the derivative of g of x. So the derivative of g of x is equal to, that's just 1, plus x to the power of negative 1 over 2. And that's a constant, so that will fall away. And I can rewrite this as, I'm going to have 1 plus 1 over x to the power a half. Okay. Can I get in the chat a thumbs up, thumbs down? How are we guys feeling about answering questions on the derivative? It's quite easy. It's the part that we should all be okay getting 100% for. How are we doing, guys? Awesome, guys. Excellent. Can you learn?
It reminds me of this is our family.
That says noise. I know. Noise is
What's
something that most people say.
of the series?
Sure,
No.
teacher, you know you're talking to the I watched no series, but I have heard of Norse. Absolutely.
Yeah.
Yeah, guys, teacher Nelly's more with it than me. I'm an old lady. See, I'm not 100% with it, but clearly she knows where noise comes from. Awesome stuff. All right, are we ready to look at some cubic functions, guys?
Our modern family.
Oh, modern family. There we go.
Yeah.
Ma'am, can we try the one that has dy dx or something that is different from this one? Okay, I'm gonna have to find it, Tisha, because in this instance, these notes actually belong to Teacher Lee and they do not belong to me. But you know what I can do? I'm gonna put up a question on cubic functions, and then I'm quickly gonna go and look for another one that has dy dx for you, and then I'm gonna put it up. Okay, you're just gonna have to give me a bit of time. All right, so in the meantime, we are going to look at this question. I'm going to put them side to side just to make sure that you guys can have a look at it. Okay, so there's our question. Remember, guys, as soon as we have graph questions, it's very important for us to read all the information we've been given up top here. Read all of this. Okay, a lot of it is information that is relevant, and we need that information in order to understand what's happening over here. Now, I'm going to give you guys a couple of minutes with this. I'm going to look for a question for Tisha. Okay, let me know in the chat, guys, if you're doing okay. If you need a bit of help with this one, we're more than happy to help. Okay. Tisha, I think I found the question that you're asking about, and it is quite, it's quite a nice one, actually, now that I look at it. Okay, I'm going to screenshot it quickly and I'm going to put it up and we can have a bit of a look at it. Okay. Teacher Nelly, can you see my screen? You are muted, Teacher Nelly. I just want to make sure.
Oh yeah, I can see your screen, but it's still just the cubic function.
Okay, awesome. No, not yet. I'm about to put it up, so that's why I'm asking. I just want to make sure that we're still, still on the same place, all of us. Excellent. I'm trying to make sure we don't run out of time.
Yeah.
Look, these classes go by so fast. Hey, Teacher Nelly.
They do.
Before you know it.
It was like 2 minutes left from the last class.
Literally, just now.
Yeah. They say that time flies when you're having fun, which means you guys have been having fun doing that.
Yeah, absolutely. Math is just so fun. I agree. Math is really fun. This one is a bit blurry and I want to delete
it. Some of them's like, ma'am, I'm dead.
Oh, so I'm just saying, math is kind of fun, especially when you know what you're doing. That's the best part. All right, guys, let's look at these questions quickly. All right, so when we look at number 10.1, we can already see that there's quite a lot of work to be done because it's already worth 5 marks. And we know that because we're working with a cubic function and we're trying to find points on the graph. We're trying to find points on the graph that that have 2 specific things about them. Okay, now if we look at B, okay, if we look at the idea behind B and behind A, we know that somewhere this B point over here is going to be a derivative, right? And this point over here is also going to be either a point of inflection or something very important is going to be happening there. So if we're going to be looking for the values of A and B, we're going to be looking for the derivative of each of those or of that, and we're going to want to compare it to the original graph to see kind of where they match up. Okay, so we're going to look at, is it h of x? Yes, okay, h of x, this is 10.1. We're going to look at h of x is equal to ax cubed plus bx squared, right? And we're going to find the derivative of that. So we're going to go h, derivative of x is equal to 3ax squared plus 2bx. Okay, now there's something very important that we know. We know that the gradient at this point of B will be equal to, can anybody tell me what will the gradient at this point over there be? Of that, let's just say the straight line over there on my cubic function. What will my gradient be equal to? Yes, Kanyisile, you've got the right idea. Okay, I know that at that point, my gradient will be equal to 0. I also know what my x value at that point is. My x value is 4. So I'm going to look for the gradient at the point 4, sorry, at the point 4, right? And that's going to equal to 3a multiplied by 4 squared plus 2b multiplied by 4. And all of this needs to be equal to 0. Okay, because my gradient at that point is 0 at that point of 4. So I'm going to go, I'm going to write it the other way around. So I'm going to take the derivative of h to the power 4 and I'm going to make it 0 on the other side. So it looks like a nice equation. Okay, I'm going to have 4 squared is 16 times 3 is 48. Phew, my maths is escaping me. 48a plus 8b, and all of this is going to equal to 0. Now, I'm not done because I still don't know what a or b is, but I'm going to call this equation 1. Okay, and then I'm going to look at where my original formula would have a and b with the point, because this is actually a point on my actual graph. This is the point on my actual graph. So I'm going to look at h at the point 4, and this is going to equal to 32. Okay. Because if I sub x, whatever a and b is arbitrary, but if I take my graph and I sub in the point 4, I should get 32 out. Do you guys understand what I mean by that? Okay. Like, let's say, for instance, if I had a squared function, if I had f of x is equal to x squared plus 4, if I made my x 1, if I made my x equal to 1, I must get some answer for y out. And that would have been the coordinate that's sitting at that y point, right? So if I sub the point 4 into my function, f of 4, it doesn't matter what a and b are, my answer at the end needs to be equal to 32, okay? Regardless of what a and b are equal to. Does that make sense to you guys? I hope that makes sense. Okay. And that's where we're going with this. So we're going to take those values that we have, okay? And we're going to sub in the point 4. So we're going to have h of 4, which is 32. I'm just going to sub in 32 actually. Otherwise, I'm doing 2 steps at the same time. Then I know I've got a multiplied by 4 to the power of 3 plus b multiplied by 4 squared. And all of that must equal, and I'm running out of space again. All of that must equal to 32. Okay. I'm going to clean that up quickly. This is going to be 64a plus 16b, and that must equal to 32. And that is my equation 2. Now, if I have 2 equations with 2 unknowns, what am I going to do, guys? What am I going to look for? How do I find a and b in this instance, guys? What would I use? You learned about it in grade 10 and 11. I can promise you that much.
Simultaneous equations.
Simultaneous equation. Excellent. We're going to use a simultaneous equation. So I'm going to take 2. I'm going to take equation 2 and I'm going to multiply it by 2 so that that's 16b. Oh, no, equation 1. I'm going to take equation 1 and multiply it by 2 so that I can have 16b and 16b, and those 2 will cancel out. Okay, so I'm going to take equation 1, multiply it by 2, and that's going to give me 48 times 2 is 96. Hey, 96a, sure, that's a big number. Plus 16b is going to equal to 0. And then my equation 2, I'm going to pop it in here. That's going to give me 64a plus 16b is equal to 32. And then I'm going to take equation 1 and minus equation 2. So minus that whole thing. Minus it. 96 minus 64 should give me 32a, and this will cancel. 16b minus 16b will go away. And then I'm going to get all of that plus 0 is equal to 0 minus 32 will give me negative 32. And therefore my a is equal to minus 1. Okay. And then I can use any of the formulas that I have to sub a back in. I think we should use this formula that comes from the original rather than the derivative in case we've made a mistake somewhere. And you can sub it back into that formula to get the answer for A. Okay. I hope everyone is with me. Please, guys, ask any question if you're a little bit stuck or you need me to re-explain something. Please let me know, and I'm more than happy to explain. It's just these big numbers. I'm not good at multiplying big numbers, guys. I also still use my calculator sometimes. Okay. All right. So from here, I can sub it back into this formula. I'm going to get negative 64 plus 16b is equal to 32. I can put it into that formula. And I'm going to take that over. 16b is equal to 96. Okay. B is equal to, teacher, maybe do you want to help me here? B should be equal to 6. And that's correct because they've actually asked me to show that A is equal to -1 and B is equal to 6. Okay, so guys, they're actually doing us a bit of a favor by telling us that A is equal to -1 and B is equal to 6. Because if you couldn't find these two values, there's a very good chance you wouldn't be able to do question 10.2, 10.3, and 10.4. So they're actually doing you a favor. Now you know what A and B are, even if you don't get 10.1 correct. And they're being very nice and kind to you guys. Okay. I just want to know, for the sake of time, would you guys like to continue with this cubic function? Or do you want me to go back to that dy d over dA question that Tisha asked me to find for her? Because I have found it. If you guys can just take a vote in the chat. Can you see this says the one before? I'm getting one vote. Tyler says cubic function. So I have one vote for each. Kulani says we can continue. Okay. Okay, Sababuma says she wants to go on with the one before. I don't know how I'm going to marry these two ideas unless I go to question 7 and I ask you guys to take a screenshot and you guys can continue with that. And then I'll ask Teacher Lee to pick up from there and then we can continue with 10.2. I think that might be the better solution because we unfortunately can't be in two places at once. Okay, so I'm going to go down here. And if you guys would like to take a screenshot of this question, the one that Tisha has asked for, you guys are more than welcome to take a screenshot of it and do this. It's very, very similar to the one we were doing before. There's just a little bit more going on in question 7.3. Okay, I'm going to give you guys 1 second. Okay, Oratile says, I'm kind of struggling with 10.1. If possible, can we please try a different one? Sure. So remember, Oratile, you're going to use kind of the same process again and again, okay? Because there are points on your graph where your derivative and your cubic function are in the same place, okay? So we're always going to be able to solve it simultaneously, okay? All right, I think we do have another one over here. Okay, but in this question, they actually give us the coordinates or the A and the B. Okay, I think we should do, can we try doing 10.1 again, guys? Just so we can get an idea of what the question actually wants from us. Okay. I think I'm gonna do this one again. All right. I hope that's okay with everyone else. Okay, if you feel like you're okay with 10.1, can I ask you to move on to 10.2? I just need to position this in such a way that you guys can see everything. Okay, There we go. All right, so that is the whole question. If you are comfortable with 10.1, you can move on to 10.2. But for those of you who'd like to look at 10.1 again, we're going to go over it again. Okay, Oratile, I will try that at the end of the lesson. Otherwise, we're just going to run out of a bit of time. Okay, because I'm going to keep doing it up and down and it's not going to be okay. All right. Okay, so I'm just going to explain the concept one more time, guys. So I want to ask you guys, if I had to look for the gradient of a straight line that goes like that, what would the gradient of this type of line be? What would it be at that point? Okay, because it's a straight horizontal line, the gradient is going to be equal to 0. And how do we find the gradient of a function? How would we find the gradient of a function, guys? How would you find the gradient of a function? We would find the, what would we look for?
First derivative equal to 0.
We would, excellent. We would look for the first derivative. And that first derivative tells me that at that point, at this point B, because my gradient is 0, that means my first derivative will be equal to 0 at that point. Okay, I hope we're all on the same page. Now, I don't know what the function of my cubic function is because A and B are missing. But I do know that the derivative of that function, h of x, if I find the derivative of that function, at this point, the derivative of my function will be equal to 0. So if I find the derivative, let me write out the function first so that we can see them one right under the other. Ax cubed plus bx squared. Now, if I have to find the derivative of this, okay, I'm going to do the normal thing that we do, 3ax squared plus 2bx. That is my derivative. And I know that at the point B, which is 4 and 32, my derivative or my gradient should be equal to 0. So I can equate this thing, I can equate this to 0 because at that point, my gradient is 0. So I'm going to have 3ax squared plus 2bx is equal to 0. But I know what my x value at that point is. It's 4. At that very point where my gradient is 0, my derivative, or at that point where my gradient is 0, my x value is 4. So I can sub my x value in to that particular formula. So I'm going to have 3 multiplied by a 4 squared plus 2b multiplied by 4, and all of that will be equal to 0. And if I clean this up, I'm going to have 48a plus 16b is equal to 0. This still poses a problem because I still have a and b. I can't solve for 2 unless I'm solving in terms of the other. I'm still solving for 2 unknowns, right? But I also know that no matter what, yes, ma'am?
16b, wouldn't it be 8b?
Oh, 8b, sorry, ma'am. Sorry, thank you, teacher Nelisa. 8b, this will be 8b. Thank you, ma'am. All right. I also know, let's say, for instance, guys, let's say I have a quadratic function, right? I have a quadratic function, f of x is equal to x squared minus 2. If I said there's a point on my quadratic, or on my graph, where x is equal to 1, if I sub in f of 1, I'm going to get an answer for my y, right? I'm going to get 1 squared minus 2, and that's going to equal to -1. So that means on my graph of my quadratic function, there'll be a point 1 and -1. Okay, I hope you guys understand that. So I used, how did I find this -1 over here? I used my quadratic function. I used my quadratic function. Now, what I'm going to do is I'm going to use my cubic function because I know, regardless of what a and b are, at the point where my x value is equal to 4, my y value needs to be equal to 38. 32, not 38, 32. So what I've done essentially is I've gone h of x, h of x is equal to ax cubed plus bx squared. And I've said that if I sub 4 in, if I take h of 4, it doesn't matter what a and b are. My answer for that should give me my y value, because that's how I get the two coordinates. My x value will give me my y value. So if I sub h of 4 in here, it doesn't matter what a and b are, the answer that I should get out should be 32. Okay, is that making a little bit more sense to you guys? I hope it is. Okay, so if I can do that, then I can take that h of 4 and sub it back into my equation. I can look at it and I can go, at h is equal to, or at h of 4, right? My function for h at 4 is a into 4 cubed plus b into 4 squared. And I know that this function, at the point where my x is equal to 4, this must actually equal to 32. So I can actually substitute this h of 4 with 32. Okay. Because it doesn't matter what a and b are, my x value must give me my y value out. My input must give me my output. Okay. Then I can clean this up a little bit. Okay, I can go 64a plus 16b must be equal to 32. Now, because both of these things are the same, they share that same point, my gradient and my cubic function. I can solve for them simultaneously because they both come from that same point. Both my cubic function and my gradient, they're both at that same point. So I can take this one and I can name it 1, and I can take this one and I can name it 2, and I can do a simultaneous equation. Okay. And I think from this point, because it's an easy, not even a quadratic, it's a linear simultaneous equation. Can I trust you guys to take it from here, solve for A and then solve for B? Is that okay? I think at this point, we're looking at the same thing. Okay. All right. And then as soon as we have our values for A and B, which they have actually given us, we can take them and substitute them back into h of x. Okay, so here's my cursor. Okay, I'm just going to delete this quickly. Okay. All right, thank you, Teacher Nelly, because we have kind of run out of time. Thank you so much. 10.2 says, calculate the coordinates of A. Sorry, I'm just going to close the poll on my side because it just comes up on my screen. There we go. Okay, we're going to calculate the coordinates of A. We already know that the y value of A at that point will be equal to 0 because it's sitting on the x-axis, right? But I know that h of x is now equal to negative x cubed plus 6x squared, because they've told me what A and B is equal to. Then I know that x will be equal to 0 at that point, or my y value at A will be equal to 0. So I can sub in. I can go 0 is equal to negative x cubed plus 6x squared, and I can solve for x. Okay, I'm going to write it the other way around. Negative x cubed plus 6x squared is equal to 0. I'm going to take x out as a common factor. I'm actually going to take negative x out because it just looks neater. Negative x, and I'm going to end up with x squared plus 6x. Oh, I can take x squared out actually. X squared out, and I'm going to have x plus 6 left. X plus 6 is equal to 0. Okay. Teacher Nelly, what have I done that's weird here?
Fine. So you have...
Oh, yeah. And then I'll just have x is either equal to 0 or
Because
x
you
is
see,
equal
that's
to-
why it's one.
No, I'm lying. I should have just taken out x squared. That's why. Okay. If I take out x squared, I'm going to have minus x plus 6 is equal to 0. I know this because I need to get a positive answer for a. My a is on my positive side of my graph. Okay. So that's going to give me x is equal to 0 or x is equal to 6.